Working everyone.
Yeah, it's visible now.
Great, excellent. So, hello everyone. I'm Emma. I'm an assistant researcher at the University of Portsmouth, and this is my talk on version control of Git. Uh, First of all, I'd like to thank the organisers for this event for putting on and inviting me to come and present. So, firstly, let's get started. So, what is Git? Git is a version control software which normally uses a CLI or command line interface to interact, store changes to files, and track your changes as you're writing your papers, your projects, whatever it is. It's very versatile. Um, a Git repository stores all these changes and all data regarding the code base. Obviously, Git will then store these snapshots of the code base in deltas. These are called commits. These commits also store metadata like hash IDs, timestamps, and authors. Git has branches, which are a series of commits, These branches can be used to track changes made by specific features. I'll get onto more of these specific topics later on, but these are the core concepts that I want everyone to understand coming up. So, firstly, who uses Git? Linux, you may have heard it. I hope most people in this room probably have used it. Uh, is actually is the reason Git exists as a whole. The creator of Linux also made Git to manage the project as it started to grow massively in scale. Um, Although this isn't using your traditional GitHub, GitLab installations, which you may have heard of, it uses mailing lists, which is the more sort of archaic and traditional way of handling Git repositories. And also Chromium uses Git, which powers most of the modern internet browsers. You've definitely used it today at some point, with 1.6 million changes, 3,500 authors. It's a very big and mature project. Um, Git also is used a lot in the private sector as well as public. It is used everywhere to handle your changes in any code base that you work on, especially in the enterprise realm. It's used due to its distributed nature, meaning that every single person on a team can have a copy of the repository and do their own changes locally, and then sync them up together to broadcast changes to everyone else who is also using the repository. So, why should I care about Git? Because at the moment it seems like a very enterprise-graded tool. Well, that is true. However, it has got some really good research applications that I will carry on and talk about later. Um, but I think we should first start with a scenario of where Git would be useful. So, we're going to introduce Macrosoft, a very original name, I know. And they've got a new project called Sentence. You're a project manager. You want to manage this Sentence project for 20 developers, and you have a 1 year deadline. So this is quite a sizable task, and without Git, it'd probably be very difficult. Um, so let's get on to how Git can help us in this situation. So let's first of all understand the constraints. So we have the first constraint is you need to keep up to date with these 20 developers. You need to understand what they're working on, and sort of check in with them, see if they have any issues, that sort of thing. You need to allocate tasks to these 20 people, and you need to keep tabs on how things are progressing, to keep your stakeholders in the loop, and to keep everyone up to date. Um, how could this be done with Git? Specifically via GitHub, there are different web interfaces, primarily other websites such as GitLab, Git perhaps if you've heard of those. They are just front ends and very nice web frameworks for using Git. I personally use GitHub quite a lot. I think it has a lot more functionality than GitLab via their projects feature that I'll talk a little bit later on. Tasks are broken up into issues. So when you have to, let's say, ask developers to create, I don't know, a new text formatting feature in this hypothetical product we've made up, that would be a task or an issue. And then we would go further and we break that task up even more into what are called sub-issues. These are ways of sort of segmenting down units of work as much as we can to make the changes very easy for the people who are actually actioning the changes, i.e. developers, to understand what we want. Git branches are a key version of the version control software. So these are where you have a series of changes or commits. I'll get onto those later. and they are stored on their own separate tree, as it's called, or separate change list, which then gets merged back into your main change list in the repository. Commits, obviously, these are the smallest units of smallest units in Git. I like to think of them. So you have these are just your code changes, your yeah, there's just code changes, any plain text changes, that sort of thing. There'll be a Git commit. You'll have pull requests. These are now not necessarily a native Git feature. However, these are very common in other websites and other forms of, or things that use Git. These pull requests will contain things like a description of what you're doing, why you've done it, and they allow for other collaborators to actually review your changes before they go into the main branch or the main tree, and they will allow for these collaborators to either request changes, perhaps give comments, deny these pull requests. So not every pull request has to be successful. Some can be denied, and they will allow you to keep the code base clean or keep the project clean. And it's just a very useful tool. I'll get onto how these are used more later. These are just more like a higher up, a summary of what we're going to be covering. And CI/CD integration. So this is continuous integration and continuous deployment. These are tools that often happen during the commit phase or during the merge phase of a branch. So these will be things like running code linters, if you've heard of those, which are essentially just cleaning up your code base, automated testing for certain projects, and building certain projects or artifacts. This could be useful if you're, for example, if you're working on a paper collaboratively and you want to, I don't know, run a spell checker. That could be a CI/CD integration. Or if you wanted to release deployment, if you wanted to release papers, you could do that through CI/CD as well, where it automatically will compile the LaTeX text you have and turn that into a PDF file. So what are issues? Issues are a way of signaling or signifying a unit of work to be achieved by someone or a group of people. So they allow progress to be tracked really easily and accurately. They develop a great understanding of the deadlines and when things are ready, when things should be ready for. This again isn't a native Git feature. This is a very common addition in a lot of instances of using Git. It's very rare that you'll use Git on its own nowadays, and most of it will come in the form of GitHub or GitLab. So what I mean by good developer greater understanding is there is metadata on these issues that I'll cover later that have, for example, typical Scrum roles. If you've ever worked in a Scrum environment where you have priorities, sizes, due dates, start dates, that sort of thing. You can assign people to these issues, which allows you to say, I don't know, you want 5 people working on one issue, which is a very rare case, obviously, but you can do that. Issues should be constantly updated and can be constantly updated to reflect the changing needs of the software or the project you're working on. So in the case of sentence, we might have an issue that looks like this. For example, we've created an issue here called text highlighting. We have a problem overview of what we want people to achieve. We have an example of what it should look like, and we have some tasks we want to be carried out. Ideally, these tasks would be created into separate sub-issues, which are then able to be performed by several developers or one developer. It creates a very formulaic way of carrying out your work and a very good way of breaking down issues and forcing you to think about how you want to achieve something. So in the case of our scenario here, we have a text highlighting feature, as I said. We have an example of what we want it to look like. We have an example of how it should be implemented, and we have some basic tasks. We've also set the size to medium, the priority to P2, which is more of a Scrum term, not really too related to Git, but I think it's worth mentioning, as it does tie in heavily with the project management side of Git, which this affords us. So how could this be tied into traditional project management? This is a fairly good question because it's one of the main reasons you'd want to use Git. So it has, specifically with GitHub, you have direct integration with Kanban, which allows you to show work ready to be picked up ready to be picked up by developers who are perhaps they've finished their task and looking for more work. In a enterprise environment, you'll either be typically assigned these based on your skills, but I've also been in situations where I've been picking stuff up off the project board and working them on in my own time or working them in my own pace. Additionally, we can incorporate agile sprints into these Kanban boards, which gets allowed us to integrate directly into our code base and our units of work. They allow us specifically to we can, for example, say that we want this done on this sprint and we want these next up issues assigned in 2 or 3 sprints time, which allows for great future planning. So we also have Gantt charts as well. These are again a nice default feature within GitHub, which allow for project management to take place. We have a roadmap. We can say that we have a meeting or we have a big stakeholder meeting, I don't know, in December, and we can start scheduling issues to be ready for that stakeholder meeting in December. So for example, let's say we've told our boss we want to get text highlighting done by December. We can have this issue ready by December by using the Gantt charts and the relative relative project management tools we've been given. So this again is another point for why Git's used a lot in commercial environments, especially enterprise, is developer experience. If you're working in a big team of people, it is incredibly difficult to synchronize these changes with each other. So this is where the more sort of developer-specific tooling comes in with commits and branches and all these things. And this also sort of dictates how developers will interact with code and how they build code and how they communicate with each other. This is what I'm working on. So the commits here are fairly straightforward. You have developers commit changes to a branch, which are then pushed into the central repository. These commits will occur on branches, and these commits should be descriptive enough to show what code has changed. So this will be things like your commit messages will dictate, sorry, this should be saying, your commit messages will dictate, I don't know, I've added this new feature, or I've removed this feature, or I've fixed this bug. That will be within the commit message. These commit messages are purely for documentation purposes. They have no actual say in how Git will actually be working and how Git will be used used by the CLIs and the other interfaces that we give it. So what are branches? Developers can create branches per feature. These are very useful for splitting up units of work. And a branch is a separate subtree, as I mentioned earlier, of the main code base, which basically means that it's its own version of a code base. You can think of it similarly to if you had a Word version and you copy this Word version, you edited the Word, you copy the Word document, you edited the Word document, and then you sort of had that document separate so you weren't overwriting the main document. That's sort of what it's for. It's very good in a minute when I show you how merging works, and it will show you how that sort of really plays into the collaborative features of Git. So how do I update the main code base? This is a really common feature. This is a really common question and ask with branches because they are fairly advanced, concepts because they require what are called merge pull request and merge conflict resolution, which I'll come up to in a second. But it is very useful for us to understand how we can merge these. So a merge is basically just when we have 2 branches that are separate from each other and we want to merge them into one branch. When we've done changes on our own branches, we need to get back into the main branch. And these often contain merge conflicts. And a merge conflict is when you have, let's say, branch B has changed a file, which branch A has also changed. Git will ask you, how do you want to change? How do you want to merge these 2 branches? And this is called a merge. It will try to sometimes automatically do this for you. However, in the context of a research scenario, I imagine this will be very rare because it will not have the context it needs to be able to make an educated guess as to how it should merge together. Okay, so let's have a look at merge conflicts. Merge conflicts are a sort of the bane of the sort of pain point of I think of Git, where it requires a lot of human intervention and a lot of people often complain about how complicated this gets. So when a change overwrites code or content, which is modified by another branch, Git will ask us how you want to handle this. In GitHub, there is a nice user interface for this, as I've showcased in the screenshot. However, it can sometimes get a little bit confusing when you have hundreds of files you've changed that you also need to then, rectify with the original code base, which gets a little bit more confusing. It does require some human intervention, which isn't great, especially if you're working on large files and large amounts of content, which is where sort of pull requests come in to sort of handle that. So a pull request is mainly how we look at and review changes in the code. So, for example, we may ask, why are we removing this change if we've seen something that's a bit suspect from another collaborator? Or we might find security issues if we're looking at this in a code instance or a code context. We might look at it and go, okay, why have we decided to, introduce this potential security flaw, or why have we done this certain piece of code? We can also provide advice through these pull requests. So we can say, let's fix this grammar here, let's fix these language issues. And it's a really good collaborative tool to help with just making sure that we're all on the same page and we're all developing or producing papers or research or any form of content in a constructive way. Some configurations in GitHub specifically, and I think GitLab 2 has this, will prevent you from merging commits unless you are the owner of the repository, and even then you will need approval from one other person on your team. This isn't a hard and fast requirement. However, I've seen it used a lot in enterprise environments in order to make sure that in the case of compromise of, I don't know, another developer's account, we can make sure that those commits are, not going to immediately go live with potentially broken or vulnerable code. So how does this actually look in practice? So we can see here we have our main branch. This will be, I don't know, in the sentence scenario, this will be a this could be your main product. And then we say, okay, we want to add that highlight feature. We'll then branch off of the main branch from a very specific commit in that history, or this specific change in the history of the main branch, and we'll create a highlight feature. This highlight feature will then have its own series of changes in its own branch. And so I'm saying word branch, so I can imagine that can get quite confusing. And we also have the new font feature branch as well, which will have its own series of changes, and then we'll merge it back into the main branch using those merge conflict resolution skills I mentioned earlier, and the pull requests. This again, pull request is not a native Git feature. However, it is very common to be used in, for example, GitHub, GitLab, and those other forges, as they're called. So how can we leverage this for our research? This is a research talk after all, and it's specifically on 6G. So we need to make sure we can actually tie this back into how we can, as researchers, produce more valuable research and collaborative research. So firstly, if we look at the latex integration, we can see that we can easily add new packages to it. We can easily revert commits if we need to, and we can easily do some sort of plain text file formatting. Teams can easily collaborate and resolve updates without losing changes from each other, and is a very good synchronized way of doing things. So let's again bring this back to our research topic of work packages, a very common thing when we're doing research. So let's say we want to break up our work packages into issues and sub-issues, meaning that we have I don't know, we've said that we want to achieve this certain product or project or this paper, and we then need to break it down into certain issues that we can then split up amongst ourselves and allocate to our team effectively. It allows for more clear communication and more clear sort of understanding of when deadlines are and how we can go about using them. So these work packages should be broken down into some core issues, and then as we discover more while carrying out those tasks, we should also then create more issues to understand and create a more formulaic way of carrying on understanding our project. So the next thing we have is the resolving overlapping changes. So let's say, for example, I have deleted a section on our LaTeX document, or we have someone else who has overwritten a certain part of the LaTeX document. We want to be able to see why that's happened, or potentially, how that's happened. This also gives us the ability to revert changes when we want to. So if we have a look at one of my favorite features of Git is that being able to revert changes is incredibly easy, and actually uses tools that we already have. We've already discovered. So for example, when you revert a commit, it will look at the commit you've just you've done at that hash, and it will actually go about and undo those changes as another commit. So what's really common is if you have a bug in production in an enterprise environment, you will often have your commit that's caused it. You will then revert that commit, and then you will revert the revert as a pull request. I know it sounds like a lot of words I've just said there, and I can understand if that's confusing, but you can revert reverts to restore that behavioral functionality. It's a very nice and clean system that, although it sounds confusing at first, once you actually start using it, is very, very simple. And I couldn't stop this presentation without mentioning the integration of Overleaf, which comes out of the box with GitHub and Git. So the integration, the Overleaf itself has direct integration with GitHub. You can synchronize the changes directly from Overleaf without having to push any direct changes from Git, without having to do any logging with GitHub, any CLI or anything like that. It's very straightforward. From your Overleaf web page, you can simply just push to GitHub, which makes
maybe one question, Emma.
Yes.
This is an interesting feature for most of the authors in the project, and I'm just curious. I have not tried this feature yet. Because especially Overleaf now offers multiple people online editing at the same time. But if you actually hook this up with the Git, how does they actually solve all these complicated kind of multi-author simultaneous inputs and also merge and stuff? So
that's excellent. That's an excellent point. So Git Overleaf has a feature that pulls from GitHub as well. So if you have, let's say, multiple authors, they all have their own obviously GitHub accounts. When they push these changes to Overleaf, to GitHub from Overleaf, we can then resolve that as a pull request, as I mentioned earlier, and we can handle merge conflicts through GitHub itself.
Okay, yeah.
So it makes life a lot more straightforward, a lot easier. That is the last part of my presentation. I think I went through this a little bit too quickly, but you can contact me at my email here if you want to discuss the more sort of complex features of Git. This wasn't a entirely conclusive document of Git, because if it was, we'd be here for several hours. There is a lot to it, and I think has a lot of potential use cases here. So thank you for listening. If you have any questions, please let me know.
Okay, any questions from the audience? Bart?
No, I don't have questions. It just makes me realize how long it was since I've actually used Git in a production when it comes to code, and I'm sort of forgetting that it can be used very heavily for documentation, and of course, being involved in projects and proposals, it makes me think that maybe this is something we can also use. But I think for students, and especially early starters of the PhD, it should be more like a mandatory course to use Git, because you would be surprised how many undergraduate students come out from the university and they're not, let's say, proficient in it. And then they get into the industry environment and they start breaking things by merging something they did not supposed to merge, or pull something they're not supposed to pull or push. So yeah, I don't recall Git being, it's probably a part of our curriculum in one of the courses, but when you start with C programming, which is mandatory in UCD, when you do later a little bit of Java programming and Python. I don't think we use Git at all, so this is something that the faculty also has to think about. Most of the professors decide to, show it to students, but it's not assessed in any way, and I think it's very important. Whichever Git it is, whether it's GitHub or GitLab or doesn't matter really. No, it's interesting, and I hope, Emma, it's okay if we post this presentation to our website. It would be very practical, hands-on presentation that we can refer to or our students to in the near future. So thanks for this. I really appreciate this.
Thank you. It's very common for new students or people who are coming into the industry recently. I saw it quite a lot when I was working in a corporate environment where we'd have new people come on. They would do changes, or they would potentially pull or commit things that were broken. Thankfully, due to Git's sort of rigid versioning system where we have commits, we were able to easily undo those, and it really sort of provided a little safety net quite often with people who were pushing things that perhaps were quite dangerous or perhaps needed to be removed.
Yeah. And maybe a related question, because the first talk is about the privacy, and then nowadays, I mean, of course, GitHub is very popular. If you have these students projects, of course, we can just ask them, open an account, go there and do your projects with your fellows. But then in terms of more kind of crucial subjects, what Bart mentioned about projects, writing proposals, if they want to use Git, do you recommend actually university or the organization set up the host environments or whatever package directly administrated by the local organization? Or do we have any recommendation of existing kind of online types?
That's a really good question. So we have in industry quite often, we have local Git instances, or enterprise local Git instances. So this will be things like Git is a very common one. It is a free alternative to GitLab and GitHub, and it allows you as a enterprise to self-host, run whatever you want. The other option is to use GitHub Enterprise, which comes obviously at a small fee to allow you to create an organization, and that will let you then induct people into your Git instance. Same with GitLab. Most different Git providers will offer some form of enterprise offering, which will do exactly as you have just said.
Okay, thanks. Any other questions from the audience online? Feel free to raise your voice. Okay, if not, I'm very glad actually, Emma, to actually bring this up, because personally speaking, I would appreciate take up some of the contents and use the video later, even for my teaching in the bachelor course here. That's some of students, when they first start their programming projects with a couple of other kids, they are very, sometimes resistant to try new tools. But then I think nowadays it's probably good to actually make this as a training for them to get used to it. At least they know there is such kind of useful toolkits outside there. They if they are so kind of tired of sending files to each other and do this manual stuff.
No, absolutely.
Okay, great. Let's thank Emma for this talk, and then we will also continue with